So, good morning, everybody. First of all, let me apologize. My Italian is not good enough, so my speech will be in English. My speech is named Past equals Future, and we would like you to time travel with us, but I must explain you that Past stands for polyaspartic technology. My presentation will start with a brief introduction of the topics we will discuss. Then I will have a brief pass through the chemistry of these products, but I promise that it will be short and helicopter view, not really in deep. Then I will give you a couple of examples of applications in which these systems are offering these future advantages, and then I will summarize the topics discussed. So, in order to start this time travel, I would like you to tell me or think about how does the future look like. If we talk only about future, saying nothing else more, some people may think about something like that. But this is not the case for today. What I'm thinking of is the future for coatings. And the future for coatings will have two trends which are very, very important and already here. The first one is that we have to reduce the impact of our industrial activities. The impact on the environment. That's a clear topic for the whole chemistry industry. But at the same time, and I think we all agree, we are facing one of the most competitive times ever. And when competitiveness is so strong, added value is a must to survive or to keep growing. So we have some hints about how the future looks like. We will need systems with the highest productivity, the highest performance, and the lowest environmental impact. And I know some of you are thinking of the lowest price as well. We can discuss about it later on. And that's why I believe that polyaspartic technology is the future. What makes polyaspartic so special? We are talking about very fast curing systems with improved productivity compared to any other technology. We talk about low viscous color and UV stable aliphatic system. With adjustable curing speed, we talk about a system in which by blending these products you can tailor 2 minutes curing time to 40 minutes curing time, even longer. Very low to near zero VOC, so the formulations with the lowest amount of VOC are 99.9%, and film thickness from 100 micron to 1000 micron, very hard and durable films with excellent abrasion and chemical resistance and compatible to many substrates. And these are applications in which the polyaspartic systems are being used today. For this talk, I will focus on the construction, and inside construction, I will focus on flooring application. But before that, I will just give you some hints about the chemistry. These products were developed in the very beginning as reactive thinners. So very low viscose systems in order to improve the viscosity and the application, but also to improve the curing time of the systems. And the term aspartic is coming from the aspartic acid, which is this group that you are seeing here. To get the aspartic, we combined 2 molecules of maleic and acid diester with a diamine to get this aspartic. And to get the polyaspartic coating, what we are doing is combining this aspartic acid ester. We call this product family Desmofen NH with an aliphatic isocyanate, Desmoduo N, to get these polyaspartics. This is how the polyaspartic structure looks like. Tailoring this X group right in the middle, we can tailor the curing time and also the gel time of the system, and also the viscosity. And this is how the portfolio looks like. The standard, most typical product to start will be 1420, and then we can increase the reactivity and lower the viscosity by blending with 1220. We can lower the reactivity and increase the gel time with 1520, and with the new 2850 XP, we offer lower viscosity and extended gel time. And for combining with these products, we will recommend basically any Desmodur N type, but On these Thermodur N types, we will focus on the low viscose types like this 3900, 36, and 3800. That's for the chemistry. I promise it will be short, and I will go now directly straight to the examples. Go. Something wrong now? No problem. So the first example that I will take, it will be an individual's garage. I know that here in Italy as well as in Spain, not so many people is living in houses with a small garage underneath, but small garage or individual's garage can also be a small garage from a building. And why focusing first example on garage? Because if this is how the future looks like, the coating in the garage should be really resistant. So how does the coating on a garage look like today? This is a conventional system, the system which is being used today. And basically they will apply a primer with chips as a first coat. After 1 day, we will apply the first sealer coat. 1 more day of curing, we will have the second sealer. And after 1 more day of curing, we will have the garage floor ready to be entered with cars. With polyaspartics, you can think of hours. You can apply the primer with chips. After 2 hours, you can apply the first sealer. After 2 more hours, you can apply the third coat. So in total, you need 6 hours before you can enter with your car in this garage. Let's put these numbers in a different way. You wake up in the morning and you want to take your Ferrari 450 to go to the office. So nowadays, the guys will come and apply prepare and apply the first layer, the primer with chips. So in the evening, you will have your car parked in the street. And the morning after, it doesn't matter if it's raining or really cold, you will have to go to the street to take your car. They will apply the second layer, and you will again park in the street. And the next day, they will make the final layer, third coating. But the coating needs some time to cure, so still you're parking in the street. And fortunately, after 4 days, you will be able to take your car and put it again inside your garage. When we think of polyaspartics, you wake up in the morning, go to the office, and these guys at 8 in the morning, they will make the preparation and first layer application. It's early in the morning, so let's say instead of 2 hours, they take 3 hours because they need some coffee and relax a little bit. After 3 hours, they will apply the second layer. After 2 more hours, they will apply the third one, and when you will be back from the office, you will park your car again inside your garage. So, we are not only talking about near zero BOC, so we are comparing to systems which are containing 40 to 50% BOC. It's not that we are reducing all this BOC from the system, we are also reducing inconvenience for the end user, because when you are applying any system with solvents, you will feel odor for some days. It's only 1 day working time. That means that we are reducing the CO2 emissions related to the application. Why? Because the guys who are making the application are not driving to your home 3 days to make the 3 coats. They are driving only 1 day. So these CO2 related emissions, which are not so big, but still CO2 emissions, can be reduced by 66%. And again, there are lower inconvenience for the end user, because the end user is not taking care of guys coming home 3 days a week. These guys are coming home only once. Therefore, we are offering a higher added value with this system. You can offer a lower price for the same application. Why? Because even though the raw material is a little bit more expensive, and I will discuss that later on, you are saving a lot of money from the labor cost. So you can either reduce your offer, improve your margin, or you can reduce your offer and get higher sales potential because you are offering a higher added value, 1 day instead of 3 and no others. And if you are thinking of the technical performance of the system, this is how we are testing the tire marks resistance. We put a lot of pressure on the white surface which is applied with the system. It's a white coating based on the system we want to test, and the black stuff is a winter tire. And we put that for 3 days at 50 degrees to see if there are marks. And what you can see on the left is, first, there is some color because the standard systems which are being used today to improve the curing time are adding a little bit aromatic isocyanates. So there is some yellowing and some black marks coming from the antioxidant. And on the right-hand side, I promise, I don't know if you can realize, but I promise there are some marks here. But these marks are not showing any black stain from the antioxidant, prolonging the lifespan of this garage coating. If we now focus on a same application, flooring, but on a larger scale, so industrial flooring application, we can be thinking of factories in which we apply the floor, or we can think of an example from 3 years ago. The LA Dodgers Stadium was rebuilt with a polyaspartic system because these guys were playing 3 days a week. And they needed to recoat that in the shortest time possible in order to keep playing in the same stadium. But we can also think of the Ave Maria University, which rebuilt the whole flooring of the university during 4 days holiday. So now I would like to focus first on the costs, and the technical advantages has been more or less discussed. So let's make first example version 1, low labor cost. That will be the example of an engineering company having a project in the Middle East or Asia, where labor costs are really low compared to labor costs here in Europe. How will be that looking like? That will be the standard system cost. We will have a raw material cost, labor and application cost, and some supervision cost with which we can argue. But this is a very low labor cost example because we are considering only 1.5 times labor cost versus raw material cost. That's a very low relation. And these supervision costs are related to this low labor cost. The most of the times when you have projects in India or in China, or you have projects in Dubai, and the labor costs are low, it means also that the labor is not so experienced. So you have to send your engineers there, pay tickets for the plane, hotel nights, and different expenses. With this polyaspartic system, we will have 20% higher raw material cost, but you will finish your coating process 1/3 earlier. So you will reduce 33% the time. That means 1/3 lower labor cost and 1/3 lower supervision cost. That means the whole system allows for 13% minus cost well compared to the standard systems in the market. And if we remove the supervision cost, because you rely a lot on the labor inside, this figure goes down to 11.5 only. So we have advantage in terms of economy. Again, in terms of CO2 emissions, if you reduce the number of days you have to work, you are reducing the CO2 emissions related to the application. And we are offering added value to the end user. But this added value to the end user can be translated on a value proposition for your customers. So in the end, added value means or higher margins or higher sales or a combination of both. What about if we think of the same project being run in Europe? Here in Europe, labor and application costs are more or less standardly 3 times bigger than raw material cost. And the supervision cost will be relatively low. This will be negligible if we think of projects being run in the same country. But in this case, the figure is exactly the same with and without the supervision cost. Again, we have 20% higher raw material cost, but 1/3 lower labor cost and application cost. So we end up with 20% minus. That means that again, we save money, which can be spread all over the chain. You can have a cheaper project, you can have slightly higher margin for you, a slightly higher margin for the application. And we are still reducing the CO2, and didn't mention in this chart before, because I wanted to tell now, again, we talk about 100% solid system. So we are reducing the whole VOC from the project, which tends to be 40%, to only 0 or 0.1 depending on the additives. So, summarizing, we would like you to time travel with us, and the time travel starts today because the polyaspartic technology now allows you to produce coatings with the highest performance, as I think I have already shown, allowing you to have the highest productivity possible, which means reduced working time, adding value for the customer and lowering the process cost, and with the lowest environmental impact. So near zero VOC emissions and reduce CO2 emissions related to the application process. So that's why I started my presentation saying that, to my understanding, past polyaspartic technology is the future. So now we have a couple of minutes for questions. Thank you very much.